What is a neuron? Basically, a neuron is a unit which connects the input to the output, or we can say it is a unit which maps the input to the output. Okay, let's say for example we have two input x1 and x2, just like that, and we have four neurons stacked one on top of each other, or stack one below the other, right? Just like this, 1 2 3 and 4. Okay, let's say we have two outputs as well, a dog and a cat. Now a neuron takes input. Okay, so in this case all the four neurons will take one of each of the input. Let me show you how it works. Each of the neurons will take one of the x1 and x2. Let's say the first neuron will take x1 and x2, the second neuron will take x1 and x2, the third neuron will take x1 and x2, and the fourth neuron will take x1 and x2. Now, before mapping it, a neuron has to add a weight or some sort of a number to it. Okay, and that number is known as a weight. So these weights are randomly initialized. Okay, it can be 0, it can be any number, but it is usually randomly initialized. And these weights are multiplied with the input inside a neuron, just like this. So x1 will be multiplied with w1 and x2 will be multiplied with w5. Okay, similarly in second neuron x1 will be multiplied with w2, and in the second neuron itself x2 will be multiplied with w6 and so forth. All right, okay, now by this time what you need to do is basically you'll get two type of output, right? One output coming from x1 and w1 in the first neuron, and in the second neuron itself the another output that will be coming out will be x2 with w5, right? So what we do next is we sum those outputs that came from each of the input. Okay, now at this point of time, this small series or this small network that you see here, small network of neurons, this can be known as a simple neural network, or just I can just say it is a neural network. All right, now this neural network will be very linear in the sense it will be directly proportional. So when it has been given a very complex task, it will not be able to perform it, which I'll come to it in a moment. Okay, so in order to perform a complex task, you need to add two things. One is that you add a non-linear activation function, and the other one is you add another layer, another dense layer, or another layer of a neural network, just like that. And we call this when you have a layer of neural network, multiple layer of neural network, that neural network is known as a dense neural network. All right. Now the same procedure will happen once again. The output of each of the neuron will become the input of the next neuron in the next layer, just like this. Each of the output from each of the neuron will go into the next neuron in the next layer. All right. By this time, again, the weights will also be multiplied to the next layer of neurons, and hence we can get the answer. Hence we can now classify, a neural network can now classify whether it is a cat or a dog. All right, so the output will go just like that. So it looks simple, it is actually simple to understand the theory, but there are a lot of mathematical intuitions that go behind it. My job is to make those mathematical intuitions or algorithms or equations simple to you for you to understand. All right, so I also mentioned that there is activation function, right? So let's see what an activation function is. Okay, so the activation function is also known as a nonlinear function. What the job of this activation function or a linear function, nonlinear function, is to make a linear function into a nonlinear function, like the name itself suggests. Now let's take the same example from the previous slide and put it in this slide. So x1 and x2, and there we have a neuron. So the input will go into the neuron. Similarly, the weights will be multiplied inside the neuron, and then we will sum it up. After summing it up, the output that you get, or the answer that you get, you have to make sure that you multiply that answer with a activation function. Okay, in this case we denote that activation function as sigma. Let's say the output is 12. Okay, now what this nonlinear function will do is it will actually convert this number, the 12 into a number between 0 to 1. Alright, any number that comes out of a neuron will be converted into a number, or transformed. The correct word is transformed into a number from 0 to 1. Right, simple, right? But why it is used? I'll just give you a quick example of that. So what happens is, activation function itself is acting as a switch. Okay, switch in the sense it will turn off and on. Why do we need that? Sometimes what happens is some of the neurons are not actually useful for the neural network. It is just a noise. So what we do is, in order to get an accurate result, or more accurate result, not exactly accurate, a slight accurate result, we tend to switch off the neuron. Same thing happens with our brain as well. When we try to make a certain decision, the activation function itself will help us to make certain decision, in a sense that it will switch on and off a particular neuron, such that the other neurons are not creating a bunch of confusion in making some sort of a decision, right? So in this case, this type of nonlinear function or activation function is known as a sigmoid function, and we denote it with the symbol sigma. Alright, so this is how it looks like. It converts any number which is greater than 1, or any number which is smaller than 0, to a number between 0 and 1. I'll just show you with the formula how it works. Alright, first thing, let's make a sigmoid function and see how it works. So let's say the first thing I'll do is I'll import a library called numpy, which is used for numeric calculation, scientific calculations. Okay, and let's define a function called sigmoid, just like that, and we'll pass it an input variable like z, and then we'll return the function. So how we return the function? The formula of a sigmoid function is, you divide 1 with 1 plus 1 plus numpy dot exponential, and then minus z. Alright, so this is the formula of a sigmoid activation function. So now if you call that function, and let's say you give a number like I told 12, it will convert that number to a number between 0 and 1. Okay, so this means that the number is 99%, or the neuron is 99% active. Alright, similarly, if you give a number which is negative, let's say highly negative, so let's say I'll give 1 2 3 4, so it will convert the number to 0. Alright, so this number basically makes no sense to have it in my network. So basically I can turn this number as 0. Okay, so now let's say you have a matrix. Okay, you have not a matrix, a column vector, or I can just generate some random numbers. So if I generate some random numbers just like that, and I have a column vector, okay, and I pass this column vector inside the sigmoid function, I'll just reduce the number. I'll just keep it like, let's say 5. I'll just keep it 5, so that it's easier for us to visualize. So now it looks something like this. But before that, let's do one thing. Let's say that this is my x1. So I can write np.array or np.random dot rand, and then I'll pass 5 rows and 1 column, making it a column vector. And then if I want to print x1, I can just print just like that. So these are my numbers. Okay, so if I pass the same x1 inside a sigmoid function, it should look something like this. Okay, now let's say that let's give some negative numbers as well. So what I'll do is, I'll say linspace, np.linspace, and I'll say that I want numbers from -5 to +5, and I want 10 of those numbers. Okay, so linspace will generate numbers from -5 to 5 in a equally spaced manner. Okay, so let's see what will happen now. You see, the numbers are not negative anymore. If all the numbers are positive, and all the numbers are being converted from 0 to 1. You see, this number is the lowest, whereas the 5 is the highest. Okay. Similarly, if I do it for 50, you will see one thing, that the least number, that is minus 50, will be converted to, yeah, almost 0. If you see, if you look closely, this is almost close to 0. So it means that when you get something like this, it basically means that you have 22 zeros in front of the number that is 1. So you say that you have 22 zeros after the number, before the number 1, 9 and so forth. So basically this, if you put it in terms of limit, tends to 0. This basically, if you have any idea about uh, calculus, then this will be considered as 0, right? So that calculus we'll talk in a later video, but for now this is how it looks like, right? This is why we use a sigmoid function. If there is a number which is less than if there is a number which is less than 0, it will be converted, that number will be converted to a number within 0 to 1.